welcome to this webinar. Today, I'm going to talk about, this is the first part of our series, and today I'm going to talk about how to utilize cache, how to create your cache rules, how to basically leverage this function of ScaleArc. Our agenda for today is pretty busy. The presentation is going to take about 20 to 30, maybe 35 minutes, and then during that presentation, I'll introduce you to the idea of caching in ScaleArc, why it's a good idea to cache, what should you cache, and how does it actually work within ScaleArc. And also, I'm going to show you how to set up a simple caching rules. I'm going to show you how to set a time to live parameters for them, and just kind of basic setup, how to set up the caching in your ScaleArc instance, and then I'm going to dive a little bit deeper into a little bit more advanced options of caching, such as caching store procedures, and then utilizing maybe some dynamic regular expression rules, hints, or and also how to leverage our REST API to integrate with your application in this particular context of caching. And after that, we're going to have a Q&A session. So if you have any questions, do not hesitate and ask them in the questions panel. And I'm going to try to address as much as we can at the end of the session. So to get us started, I guess the most important idea, why would we want to cache? What benefit of caching do we get? And it's a pretty simple, pretty trivial question. Obviously, it's performance. It's a performance that is the reason why do we want to cache. We want to have the data as soon as possible available to the user. If it's a static data, why do we need to query it every time? Cache is critical in those kind of circumstances. And why do we want to cache with ScaleArc? Well, you could develop your own layer of caching within your code base. You could do it within your database, but that all complicates your code base. It basically adds a non-business related logics within your code base, within your data structures, and that's not necessarily a good idea. By introducing this mid layer between the application and the database, you can actually lower your development cost by simplifying your code base, and that also leads to simpler changes to the code base, and also this decoupling of caching technology allows you to perform any migrations in the future much easier. So obviously, performance gains are a key driver, but also there's another aspect of caching that, as you have read the subject of this webinar, you might be aware of, which is the reduced hardware pressure on the database server. And this is quite significant that we see across the board when we talk to our customers, that caching allowed them to lower the hardware requirements for the database server, which in turn can be reflected in the licensing costs. Maybe when you grow, if you're a growth company and you grow, you have a bigger and bigger user base. Caching can actually reduce the need that you need to scale your hardware. It will require less purely because this cache handled in ScaleArc is a very lightweight key value store, as opposed to a little bit heavier, a little bit more perhaps smarter, but also much heavier on hardware and memory cache solutions, such as caching within SQL Server, for example. And one other aspect that we found our customers are leveraging a lot is to handle the peak usage periods. Whether it's during the Black Friday if you're running a e-commerce, or whether it's some other period of the year that you have your peak usage, you have your sudden spike in your use patterns. Caching can mitigate the risk of running into problems, purely because a lot of those queries that if the customers are going and opening your website, a lot of those queries are read queries, are being triggering queries to the database servers. All of this traffic can be basically served directly from within ScaleArc operating memory back to the user, with reducing the pressure on the hardware. So this is why you would want to consider caching. And we found that a lot of customers are actually leveraging that, and those are the main reasons why they want to consider caching. Now, the next question that you might ask is, what would you want to cache, and when would you want to cache it? And a straightforward answer: you want to cache your frequent queries and your slow queries. Like, frequent slow query is your silver bullet to cache, basically to have a biggest performance gains. Now, sometimes it might not be as obvious. You might want to give it a little bit of thought into what else can we cache. Perhaps any search type ahead text boxes, or some parts of the web page that are automatically refreshed, or some reports, some dashboards that are automatically refreshed across various users. Maybe they don't need to see an update of data every time they refresh it. Maybe once a minute or once every few seconds is sufficient. And then each of those users might be running very same query, and we can basically merge them all into one and return this result set from cache. So those are the situations that we found our customers are using the cache frequently. One other aspect is the reports. In pretty much any system, there is some reporting engine that is analyzing data, producing some sort of reports, whether it's a SRS, whether it's Cognos, whether it's something else. Those reports, a lot of times, they have common parts to them. They share some data, whether it's a header part, whether it's a footer part, or whether it's some sort of a data definition part. A lot of times, this data can actually be cached as well, and that allows this reporting engine that perhaps have a very tight SLA to generate hundreds of thousands of reports. It can mitigate this kind of running of a lot of unnecessary repeatable queries, and then just run the queries that differentiate the reports, and then every other shared query would be returned from cache. So this is another situation. I've already touched on e-commerce. Of course, any product searches, layout details, product categories, drop-downs, those kind of things can be cached. One other use case that is relatively common with ScaleArc is images and those kind of content delivery. So ScaleArc can actually be co-placed with the application within geographically spread locations. And then when users access ScaleArc within their own local location, they can get this data on very low latency, these images directly from ScaleArc, if they're kept in the database, of course. And there's many more situations when you can cache some data, and this is very domain specific to your application, to the nature of your queries. Some can be cached, some cannot be cached, some can be maybe cached with a very short period of time, just to allow other users to leverage the same result set, and some might be cached for a longer period of time because the data is not changing as frequently. Now, how does ScaleArc cache this data? How ScaleArc handles it? Frequently, I get a question like, how does ScaleArc figure out which queries to cache? How does it store the data? How does it return the data? So just to give you a kind of a high-level overview, ScaleArc uses a key value storing behind the scenes. The keys are actual hashes of the SQL queries. Now, they are specific to the database and user, depending on the settings, and I'm going to dive deeper into that in the following sections. But in general, it's a key value store where the key is the hash of the query. So it is very efficient in finding the appropriate result set. It's essentially a matter of nanoseconds, and this is because they're being kept in the operating memory of the server. So ScaleArc needs to be provisioned with enough memory, because it will reserve the amount that's specified for this for the purpose of cache. The way ScaleArc recognizes which queries are meant to be cached and which queries are not meant to be cached it's using a pre-compiled regular expressions, and it's pretty important. Those regular expressions are pre-compiled. They're ready to go to parse the strings once the SQL is being deciphered from the protocol by ScaleArc, and then results at the first time the query is executed within particular period of time will be stored within this key value store. So with no further ado, let me begin the actual part of the demo when I'm going to guide you through this section where we will set up a simple cache rule at the beginning. Then we're going to dive a little bit deeper into a few other aspects of caching. But for the beginning, one thing that you need to bear in mind, you need to enable caching for your particular database for the user. So let me jump over to my cluster, my ScaleArc cluster. So this is my ScaleArc instance. I have two clusters configured. We're going to use this always on cluster here today for the demo. And the first thing that you need to do to be able to leverage to use caching within ScaleArc is to jump into this users and DB section and make sure that our database is selected for caching. What it means, it just needs to be sit here in the selected databases corner on the right-hand side, and only then ScaleArc will consider for caching. By default, it would have been on the left-hand side, so that needs to be enabled first. So this is pretty critical because otherwise you will not be able to cache any data for that database. So once we enable this database, we're ready to go on caching. So in order to specify our first caching rule, I'm going to jump into our analytics page here, and this will load quite a lot of data actually behind the scenes to show us a little bit of a kind of overview, high-level overview of the traffic within our database. And once we drill into that traffic, we'll see the details, the actual queries, and we'll be able to recognize which queries can we cache. So I'm going to just hide this one here. So in here, we can see how many queries are being run over our clusters. I'm just going to select like a recent hour here within this particular time zone, and then and drill into it. And now we can see our databases. So this cluster has there are two databases on this server, on this cluster, master and ScaleArc demo 1, which we're using for the purpose of this demo. And pretty much the whole traffic is going against ScaleArc demo. There is 114 queries run against master. So that's why it's a little bit perhaps not very interesting. Now, if we drill a little bit deeper here, we can see that it's being spread across various servers. We can see some details of the traffic here, but I want to drill even deeper just to see this actual query details. So on this graph here, straight away, we can see the quadrants of frequency versus the speed of the query. So our pink quadrant here is the biggest offenders, of course. So those are the frequent slow queries that are running against our database. So we can straight away see that our application will benefit hugely if we create a caching rule for this one. So let me actually proceed and do that. I'm going to hit a cache button here just on this query. And what ScaleArc does here, it auto-generates a regular expression based on this query. So it will recognize that, okay, this is an ID, it's a parameter, and there is a where clause, there is a from, there is a table name. ScaleArc understands that and creates a suggested regular expressions, which we're just going to use. It's most of the time it's correct. It's the one that we want to use. And I'm going to create a 1-minute rule, 1-minute time to leave rule for this statement, and add it to our cache. So we created a cache rule successfully. Let me jump over to our live monitoring tab. I'm going to just refresh this screen just to make sure that we have the most recent data. And what we can see here is on our client-server connections graph that immediately at this point in time I've added the cache rule, and immediately we can see perhaps 30, maybe 40% increase in the connections accepted from the clients. So my tool that runs behind the scenes that triggers those queries will just trigger it as much as it's possible. And this is why by adding this cache rule, we actually increase the capacity of this cluster. So by 30%. So we can see that straight away here. Similarly, the queries per second went up as the connections. What's interesting here is that queries count per server actually went down. And this is perhaps even a 50% decrease of the amount of queries that are being run against each server. And the reason for that is that right now they're being returned from within the cache. So this spare capacity of a SQL server allows us to see this another benefit here. Essentially, our average response time for queries per server decreased, and this is thanks to the fact that we actually do have a spare capacity on those servers to process those queries faster, because less queries are hitting those servers, because a lot of them are actually handled by cache. And we can see how many of them around here. So with this cache rule, 71% of the queries are being they have cache hit rate. So that means that they're being handled by cache. So this is pretty good. Of course, in the real world application, you perhaps will need to define 5, 6, 10 rules, depending on the structure of application. But there is usually some 1 or 2 offenders that can give you a huge benefit in overall performance. So, this is the way we created simple caching. Let me go back to our analytics panel here, and the next step would be, well, let's see what else can we do. So you can actually zoom in here to see, okay, well, maybe some of the queries from this section will be relevant. Let me just do, I'm just interested in reads. Okay, let me just do it again. Okay, so this section. So we can see that there's few more queries in here that perhaps they're good to cache. This is a good one. It seems it's actually doing select distinct, and distinct operation in SQL Server is relatively expensive operation. It's not overly expensive, but it does take CPU time. So perhaps this is another one if we want to continue caching. So let me go back to the presentation, and so this is how you would this is how you would usually, this is the simplest possible approach to create caching rules, and in the 80% of cases this is sufficient. Some cases, some customers require caching of store procedures. Some customers require a little bit more sophisticated caching. So I'm just gonna move into that now. So right now I'm gonna talk a little bit about the caching of the store procedures, because although it's a very similar, very same mechanism, it's slightly different in the way ScaleArc actually treats store procedures. Because of their transactional nature, ScaleArc by default will route all the store procedure traffic to our master database as the traffic that meets the requires transactional integrity. So in this way, we will have to tell ScaleArc that those store procedures are okay for caching, and then create the cache rules. I'm going to show you also how to create kind of a little bit of hints. If you want to perhaps a little bit more dynamic caching, we'll go through cache invalidation through UI and the REST API, and also I'm going to show you a few settings. So I'm going to do that. Let me just jump back into our ScaleArc, move back to our clusters section of ScaleArc. And so we need to start from a different screen in order to cache the procedure. It can be done from analytics screen, but it's actually a little bit easier. It's a little bit more intuitive to do it from over here. So if we head into our transparent cache section, we can see that there is a tab called Stored Procedures. And within this tab, we can drill into our database that we want to identify the store procedures in. And there is a button called List Store Procedures. And what that allows us to, ScaleArc is able to understand and read schemas from the database and identify which queries are read-write, which are read-only. And further to that, we can actually click on those and recognize what is this store procedure actually doing. In this case, this store procedure is actually just simply selecting a company name, top one, order by ID descending. So the most recently added company name. And also I've added the UTC date to this result set. So just purely so we can see whether the data is coming from cache or whether the data is coming from the SQL Server. So I'm going to select this rule, select this store procedure, and add it as a cache rule. So right now we have 1 minute cache rule. I'm just going to increase that to 5 minutes. Okay, and then I'm gonna disable it for now. Just for a few seconds, I'm gonna disable it just to show how it works before we enable it. So I'm just gonna save that and go into our SQL Server Management Studio. So I have this store procedure here. I can execute it. Okay, and this returns our company name and a UTC date. So we can see it's 08283. 08 seconds, 283 milliseconds. And if I run it again, it's going to keep changing. So 17853 and so on and so forth. Now, once I enable this store procedure, caching, once I go back here and I'm going to start executing it, you can see that it's 33783. But if I run it again, it's actually going to be the same. It's not good. The UTC date will not change within this query. And this is because it's actually coming back from the cache now. It's no longer hitting SQL Server. So with this simple, slightly different way to do it, perhaps a little bit simpler using the store procedure list, perhaps the DBA should sit down with the application lead, developer lead, and then just sit down and identify the store procedures that can be cached and just click over them and create some rules. And this is how it operates. One other option that I want to show you is this shared cache. This is off by default. Let me just switch it back to the default. This is an option that can be that some of our customers find useful, the other find completely useless. And the reason for that is depending on your application design. If your if your application is using one login to the SQL Server, this application is irrelevant. But if there is a bunch of different logins that your application is using, and you want to share cache data across those users, this is the option you're looking for. So let me show you how that works. If I take this store procedure and run it here, I'm going to see that this is 2609230. But if I have an open session, this is ScaleArc user, I have a ScaleArc 2 user session here. So let me just open a new window with this user and run this within this window. We can see it's 2626167. I'm just going to run it again, 2626167. But this user receives a different data set, yeah? It's actually 09230, 09230. So they are receiving a different data set, even though they're hitting the same database, the same store procedure. And this is because this option is now switched off. As soon as I switch on this option, and go back to our SQL Server Management Studio, I can see it's 56920. It's the UTC time, and then it's 56920. So ScaleArc 2 as well as ScaleArc user, those two separate SQL Server logins right now are going to be receiving the same data. So this is perhaps a critical setting. Sometimes it's a little bit surprising when our customers are creating a rule and then they're still seeing a different data even though it's cached, or they're still seeing not as huge performance improvement as they would expect. So this is one of the options to keep in mind when setting up the your cache. So another option that I want to share with you today is a little bit of a trick that you can do in order to allow your developers to have a little bit more control over your caching rules. And this is if for any reason you don't want your cache rules to be driven from this UI, you might want to consider that. You can create a pattern that is actually reflected as a comment. So in this rule that I've created a regular expression that is matching just a comment. It's a TTL 16 brackets, and it corresponds to 1 minute time to live. So, and this regular expression indicates that every time I will add this comment onto the query, this query will be considered for caching of 1 minute. So in order to show you how that works is I've created this rule here, and I have a window opened here that basically represents this. So if I run this query this way, I will see that every time I run this query, this UTC date will change again. 697, 910, 683, those numbers are changing constantly. But if I add this comment, because I've created this rule, it's going to stay the same. It's 18, 6, 7, 6, 7 every time I run this query. So this is pretty strong, like pretty powerful feature. Depending on the architecture of the application, sometimes the queries are being kept in separate layer as such, and then just called from the application. So this can be leveraged then just by appending those rules to your queries. We can define, we can designate that this should be cached, this should be cached, this should be cached, instead of going through the separate regular expression rules. And we can allow actually developers to perhaps make a little bit of decision there. What should be cached? How should we cache it? So this is a powerful feature that can be leveraged this way. Another option that I mentioned that I want to show you during this kind of advanced caching session is the invalidation of cache. So what I'm going to do, I'm going to go into ScaleArc now. You close this panel for a second and go into our API section. So this is ScaleArc has a very rich API that can be leveraged for pretty much everything that you can do from this UI. Can also be done through the API. So pretty much all the settings. In order to do that, it actually has nice interface that will help you achieve that. So first step, to access our API, we need to get an API key. So I'm just going to use my ScaleArc login to get this API key. And the API key is fetched. And then I'm gonna select an endpoint. Those are all the various endpoints, and we can read a little bit more about them in the documentation. But most of the names are actually self-explanatory. So if I find a rule that is called cluster ID, database ID, and then pattern ID, cache manager, delete. So this is the option. This is the endpoint that can be leveraged for clearing up the cache for the particular pattern. So I'm just going to generate the query, generate the kind of serial command for this. And what that gives me, it actually pre-populates all the details except for the cluster, database, pattern. So we need to add those in. ScaleArc has a nice function that enables us to do that from over here. So we don't need to go and figure out what is the ID of our pattern. We can actually just select the pattern from the menu here. And it's going to be our TTL 60. Okay. And we have a ready to go command. And once I'm going to copy that over to my shell, once I hit return on this, it will clear the cache. So before I do that, let me just run this query just to make sure that we can see a change in the value. So right now we have this 41213 value there in cache. And just going back here, go back here, hit return on it. And we can see that deleted cache for pattern successfully. If we go back here, we can see that this value has changed. So this is very useful if you perform any sort of migration, if you perform a release, if you're doing weak releases and you want to make sure that your cache is invalidated. You don't need to go to the UI to trigger this option. You don't need to do that manually. You can just embed it in your release script, and all of a sudden, this will happen every time you run your release script. This API can be leveraged for much more than only that. Of course, you can set up your rules through API. You can delete them. You can change them. You can do all of this. All of the options that you can do through the interface. You can also do UI through the API, and this is super useful if you want to automate things. Before we go back to the presentation, summarize, and move into the Q&A session, there is a one option that I want to share with you, and we found that a lot of customers are basically asking about that or stumbling upon this property of the cache. So if we go back to our cluster settings here, there is a cache tab on it, and this option here, it's a very important option. A lot of times we found that some result sets that the cache is leveraged for are the big result set, the big queries returning big result set, and frequently the default, which is 1 megabyte in ScaleArc, is just not sufficient to cover this. And so in order to be able to cache the result set greater than 1 megabyte, we need to change this property, perhaps add a few zeros, and then apply it. And in this way, right now we're going to be able to handle about 10 megabytes of data instead of what default 1 megabyte. So this is pretty critical, and it's an option that a lot of customers we found need to adjust because they were just reaching just over megabyte, or maybe they were returning images that were 2 or 3 or 5 megabytes. So this is something that I just wanted to mention before concluding this part of the demo. So for a quick recap, we went through store procedure caching. I've briefly touched on the how the regular expressions can be leveraged to implement a little bit more than just standard query caching by matching the actual query with caching hints. And then I briefly touched on the API. There is obviously much more to API that can be leveraged. But and if you have any questions, if you want to dig deeper into it, do ask questions, or do just go and figure out. It's very, very easy to use. And then I've mentioned those two options that are worth mentioning in the kind of cache universe that we found our customers. Perhaps some of you asked questions about, which is the shared cache and maximum query response size setting. So with that, I think that gives a good overview of the caching functionality in ScaleArc. And I'm going to move over to our next part of the presentation, which is questions. So Suzanne, do we have any questions?
Yes, Larry, we actually did get a few questions submitted, and as a reminder, you can still submit them through the questions pane in your attendee control panel. The first question we got was, can I see replication latency issue history from ScaleArc?
I presume this is the replication lag that the question is referring to. Yes, so there is option in ScaleArc. It's not so much cache related. It's more of a general function of ScaleArc. ScaleArc is able to observe replication lag by performing simple writes and reads to the database. It requires a little bit of a setup, and perhaps that's something that we can touch on on the other sessions. I will definitely gonna take a note of that. it requires the creation of few structures in the database, and then ScaleArc is able to monitor the replication lag to see whether any of the databases within cluster is lagging behind. And if it is lagging behind over a certain threshold, ScaleArc will actually route away traffic from this database to allow it to catch up with the others. I hope that answers the question.
All right, our next question is, do we have to add master database to gain the caching using procedure execution?
No, absolutely not. I think I was just basically overeager by adding this master database. You don't need to add it. You just need to add the databases that you actually going to be executing your queries within to enable for caching. ScaleArc, when receives a query, takes into equation the user, obviously, because of the shared cache paradigm, and the database, and then the hash of the actual query. So you need to make sure that your database that you run your query against is enabled, but you don't need to enable a master.
All right. Can TTL be defined for 1 to 2 days instead of 1 hour or minute?
Absolutely. I'm not sure if there is any limit on that, but it's probably some sort of an integer limit in terms of days or something like that. But in general, yes, it can be defined for 1, 2, 3, 5 days, or basically more. And this is not uncommon scenario whereby our customers would just define it like very, very eagerly in the future, and then they would use the invalidation mechanism to actually invalidate the cache, because if they have data that is only updated per request on some demand, perhaps this is the way to go with it. Just cache it indefinitely and then refresh it every now and then by triggering this API call or manual refresh from the UI.
All right, and looks like our last question. Can you demo how to set up TTL 60 again?
Sure. Yeah, I can. By the way, this session is recorded, so if you want to go through it and kind of revisualize it, absolutely fine. I can absolutely jump into my ScaleArc instance here and very quickly go over how did I set it up. If we go into our transparent cache and into our cache rules tab, which opens by default into our database, you can see that this is the rule that I've set up. So let me just remove this this bit over here. I'm just going to copy it in the clipboard, the regular expression, so I don't need to rewrite it. I'm just going to delete that. And now this rule is no longer visible. So in order to create one, I just want to add it, type my regular expression. And this is just to explain, I don't know, depending on your familiarity with regular expressions, / needs not to be escaped, then a star needs to be escaped with a backward slash, then TTL brackets needs to be escaped again with a backward slash, 60 doesn't need to be escaped, then a bracket escaped, star escaped, and then /. So this 60 seconds corresponds to 1 minute, and to actually answer the other question, we can specify it manually, and we can specify for a few days or something like that. Just keep it consistent with 60 seconds. I'm going to leave it as 1 minute, hit save, and that's it. And this is the way the rule was set up. Okay?
Great. Well, that is all the questions that we have for today. So I'd like to thank everyone for attending today's webinar. And as a reminder, you will receive a follow-up email with a link to view the recording as well as the presentation slides. And as a reminder, this is just the first part of a 5-part series. So you should be seeing other invites if you haven't already come across to register for the remaining sessions. On behalf of Ignite Technologies, thank you for joining and enjoy the rest of your day.
Thank you, Suzanne, and thank you, everyone.